11.4 is about conditional probability. It's pretty easy when they give you a table. We hit this pretty hard in geometry. So if we're looking at this, it's the probability of female grad school. Conditional probability, when you're doing something like that, is the probability of A given B is equal to the probability of A and B divided by the probability of B in this case. So what we're looking at here is the probability of female given grad school. Now, it's kind of easy when you're looking at a chart to do this. Well, how many females given grad school? So all we care about is this column. So there's 1,954 females. Out of how many total went to grad school? So if we look at that, that's 3,303 went to grad school. So that's about 0.59% or 59%. Okay? So then they ask, what's the probability of female? So again, it doesn't matter now. There's no given. We're just looking for the number of females. So what I want to do is add up this whole column and divide it by the total number of students. So that whole column adds up to 9,933 divided by the total number of students, which is 17,472. Punch down a calculator, divide it, get about 57%. Okay? And then problem 2 talks about what's the probability that a sample of recycled waste is paper. So again, what are we looking at? We know that it's recycled waste. So we're not really caring about the not recycled, we're looking at the recycled. So the recycled waste is paper. So this 45.2 is what we're looking at. So what this is really asking, what's the probability of paper given recycled? Okay, so that 45.2 is what goes on top. Now what's the probability of the whole just recycled column? That's going to be 79.4 is on the bottom. So then take those two and divide it. You get 0.569 or roughly 0.57. Problem 3, what's the probability the customer pays online given the customer's mail? So what are we trying to find here? Probability of online given mail. So all we care about is the mail column. So how many mails paid online? Well, that's going to be 12 out of how many total mails, which is 20, which gives me about 0.6. Is the probability of that. 4, 85% of students graduate from high school. Of the students who graduated from high school, 90% are happy with their jobs. Of the students who didn't graduate, 60% are happy with jobs. This right now kind of screams a tree diagram to me. So let's draw one. Okay, so 85% graduate from high school. So let's talk about graduate and not graduate. 0.85. So that would be 0.15 down here. Of the students who graduated from high school, 90% are happy with their jobs. So happy is 0.9. Not happy would be 0.1. Of students who didn't graduate, 60% are happy. So we have happy are 0.6. Not happy is 0.4. Now I didn't put the question here for a purpose. What I want you to do is total up each one of these first. It'll make your life a little bit easier. So the top there is 0.765. Here's 0.085. .09, and the bottom is 0.06. The nice thing about a tree diagram is you can always check to see if you add up all those together, it equals 1. So what this question is looking for is what's the probability that the person from the junior class of 10 years ago graduated, so graduated, and is happy. And is happy. The little and the intersection sign there means and. Graduated and happy, that's going to be 0.765. And it kind of makes my life easier to answer some questions if I total those up first.